So thank you for the invitation to be here. And as Matthew mentioned, I'm in a tree food extension specialist, and I'm going to share. Yeah, it is sticky. There's any other way I can do it with the hand, no? There. So I want to cover three main points here. One is the impact of nutrient in fruit quality, what we know and what is in the literature, a little bit on that, maybe just one slide on that. And then I'm going to share a couple of slides on a few projects, some of them funded by the Washington Tree Fruit Research Commission. And then after that, revisit nutrient management for Washington growers. So the reason why we start evaluating this idea of correlating nutrition with fruit quality is because there's a lot of information out there, a lot of literature, a lot of questions from the growers related to the impact of these different elements in fruit quality. So this is a table where we have the main elements that normally are associated with fruit quality. And I listed here a couple of citations where they show either the impact in terms of an increase or a positive impact with a triangle pointing up, and a negative impact with a triangle pointing down, or no impact at all. So what I want to highlight here is, for example, there's a lot of information, as you might expect, in calcium, relation to firmness in particular, and of course in cracking, which is one of the reasons that we apply these products. So in cracking, what I'm showing here is that it's reducing the cracking by the application of calcium, but also there's some citations where there's no impact. The same with nitrogen. We know that there's mixed ideas of, does it increase firmness or does it decrease firmness? So this is kind of the start point where we thought, okay, let's do this trial here in Washington and understand what is that relationship with fruit quality. So the first trial that I'm going to show, this is a grower that had two sites. He managed these two sites very similarly, where he was noticing that there was a very extreme difference in terms of firmness. So what you are seeing here is the frequency or the distribution of firmness between the two sites, and we have what he called the Pasco site with lower firmness compared to the river site, where, of course, there's a distribution, but the majority or the mean of firmness in the river side was much greater than the other side. There's also notorious that there's a large distribution in firmness within one block, which probably you all know that. But overall, the idea to show here is that Riverside had higher firmness compared to the Pasco site. Also, the size distribution, diameter and size distribution was very different between the two sites. Pasco site had smaller fruit size overall and a smaller fruit distribution compared to the river site. So this is the start point of the quality of these two orchards. Oh, this went ahead one. So here, this is a table that the idea was to start with the previous, The idea was to start with this one, which shows the R value, so the correlation value between the parameters that we are evaluating, fresh weight, dry matter, firmness, diameter, and soluble solid contents, versus all the nutrient concentration. So these are the correlations. Everything in bold is what is significant. So it has high probability to occur over and over. And of all those that were significant, only these were actually strong. So as you can see here, this study, for me, is one of the most valuable ones because the analysis was done at a fruit-by-fruit basis. So each single fruit was analyzed for quality, and that same fruit was analyzed for fruit nutrient concentration. So this is not a bulk, trial where we collect from different areas, where we combine the samples to get the average. This is fruit-by-fruit analysis, so it's very accurate in the sense of providing good or very strong conclusions. So these are the correlations that we found in this study. So this is an example of what it means if we want to visualize this in another way, is that we have a wide range of nitrogen concentration in the fruit, and you can see that the firmness, while it is wide, there's no relationship to that nutrient concentration. The same, because I give the example with calcium, because we know and we tend to apply calcium for this purpose, there's also no relationship with calcium concentration and firmness. Okay, so based on these results that we did in a fruit-by-fruit basis, in more than 3,000 fruit, by the way, we asked for funding for the commission, and we did this other trial, and because of the limitations in budget where we couldn't do the fruit-by-fruit analysis, we wanted to compare between different sites, 3 different sites, 3 different cultivars. We had 5 sites for Esquina and 3 for the other 2 in 3 years. So it was a very large study where the way we conducted this trial was collecting the fruit from the packing house, from each of these sites and cultivars, but in this case, we only selected the extremes of the fruit quality. So again, this. So we collected the extreme, the firmness fruit and the softest, so we can see the difference. So we didn't have to evaluate the whole fruit. It was a higher cost, so we decided this strategy. And for each of these sites, we also separated from the big and the small because the size will have an impact in the fruit firmness. So the first thing that I want to show here is that, of course, again, think about the distribution and the variability that we obtain with this firmness between the sites and within sites, sorry. And here, again, we found after 3 years, 3 cultivars, and for each of these cultivars, there was no relationship between nutrients and fruit quality. And this is an example because potassium has been attributed to have an impact in fruit size. This is the example that I provide here. No relationship between these elements and fruit quality. And for firmness, there's a slight relation, but it's very weak. So scientifically or agronomically, it's no relationship at all. This is 1 year, so only 1 year, in 1 variety, and I'm showing the results for 2 blocks. So you can see how the data looks like. Each point is a different site, and below you have the concentration of nitrogen and the diameter. And you can see that for site 1, we had a stronger correlation, 0.6 or 68% of relationship with nitrogen and diameter. So it goes up as the diameter goes up, a positive relationship. But in site 4, we had actually the opposite, a negative relationship between size and nitrogen, while there were no relationship with the other sites. And the same happened with other elements. So what I list here is in site 1, we have a positive correlation between firmness and nitrogen, boron, and copper, a negative relation in site 2, negative in all sites for site 4, and positive for boron, and no relation in the other 3. So, of course, it's confusing, it's puzzling, and so how we manage with this information. One, of course, obsession that you all know I have is with the calcium application, and that's why I want to provide this example in particular, that this is the concentration of calcium, and these are the four sites for Esquina. The lighter color is the firm fruit, very top, the max, and the darker color is the soft. You can see within each site, there's no difference in calcium concentration between the soft and the firm fruit. And the other thing that is important or relevant is this is the total amount of calcium that these sites apply for calcium in terms of the total amount and how much of that is applied by spray application as calcium chloride or other source. And you can see here the diversity in the amount of calcium that we are applying, but also we can see that in site 2, which by the way is one of the sites with best fruit quality in terms of firmness and also in terms of diameter, has the lower amount of calcium application. And regardless, we have no difference in calcium concentration in the fruit. What are the explanatory factors? The main ones, which sounds intuitive probably, is the variety and also the year. So for both, for firmness and for diameter, factoring both year and diameter were the biggest explanatory factors for firmness and for diameter, 20 and 23%. And sometimes when we think about the impact of the year, we tend to think also about the crop load, right? And we have a lot of information that have a good correlation between crop load and firmness. And here we have a Chelan, 3 different sites. You have the frequency of firmness. Sorry, and now it's going too fast. There you go. Then we have in red in the back 2021 and in 2022 in this gray in front. So in the first site, we had a reduction, and those are all significant reduction in fruit firmness, while there was also a slight reduction in crop load. The second site, we had an increase in crop load and also an increase in fruit firmness. And probably site 3 is the one that we are more familiar with, which is we had an increase, a decrease in yield or crop load and an increase in firmness. These differences, we can discuss it later, and I would like to ask Matthew if he has any idea, but we can think, for example, that in site 3, where we did see a big increase in firmness, maybe that reduction was very significant in terms of carbohydrate and the main requirements to be a firmer fruit, while this increase or this reduction was not as significant. So there might be some things we can consider. Okay, so why we see this, I wouldn't say contradiction, but why we see this lack of relationship between the fruit quality and the lack of relation also with the information that we see in the literature. In Washington, these sites we collect, this is the nutrient concentration expressed in fresh for the different sites. And you can see here not only the distribution of that, so very wide, so a wide variability, but also in this line here that is, maybe it's not so clear, but there's a line here that represents the mean, the average of that distribution. And in most cases, except for nitrogen, that we are within the adequate range, this is moving on its own, we are either within the range in nitrogen, or, this is Washington fruit, above the numbers that we see in the literature. And this, for me, is not so surprising because we also found the same thing for soils and tissue samples, that in Washington, we tend to have more. We have more. We have more nutrients in the soils. We have more nutrients in the leaves. We tend to be above the average when we compare with other regions and other areas where we have, and we compare the literature to. So this is one of the reasons. And then that's why I'm going to go now quickly. I don't know how much time I have, but let's go back to the basics and understand what is the response of nutrients or fruit quality with the nutrients. So maybe you are all familiar with this curve. It's a simplification maybe, but it's a good representation of how the trees will respond to the concentration of nutrients. And what it shows here is that for any organism, or plant in this case, the response, either in fruit yield or fruit quality, will have this bell-shaped curve, which indicates that when we are in severe deficiencies, applying these nutrients will have a very quickly response, a very evident response in increase, in improvement. But we're going to get to a point where we end up with a critical concentration. This is the value that we would like to sit on in our orchards, in terms of we don't want to put more than that. We want to get to the maximum level where we have the maximum response from the tree in terms of quality or yield. This is a wide range. So there's a lot of things that can be happening. And if we are sitting in this range of concentration, we have either no response, and for some elements, and I will list the three main ones, we actually to this negative impact very quickly. Those are nitrogen, so we have excess. We can end up with a negative impact in that excess level. If we have manganese excess, you can have toxicity, and the same with boron. If you have excessive boron, you will have a very clear impact in toxicity. But other elements, for example, calcium, we can apply as much as we want, and we will probably never see this decline in fruit quality. So we can be sitting in this very large amount in the fruit, in the soil, in the leaves, and we don't see the negative impact. So think about this. Where are you sitting? Where is your orchard sitting in this scale? These are, oops. What are the limiting factors that we have seen most common in Washington? One of them, in some areas, of course, it varies a lot, but drainage. So we have limited drainage, especially when we think about the Yakima Valley, but we have excessive drainage in the area with sandy soils in Mattawa, Ringgold, or Quincy area. Temperature can be a limiting factor, especially early in the spring. Some years we have very cold soils, and that can limit the uptake of some elements. Areas, you all know probably this, in the Yakima Valley, most of our soil have high levels of caliche, which is calcium carbonate, and that will increase the pH of the soil, leading to the precipitation of nutrients and make them not available. High potassium, for me, has been very surprising because the levels of potassium that I see in the soils here in Washington are extremely high. I've never seen that before. And we also have low levels in the soil of boron, sulfur, and zinc. Oops. That is not a political map, by the way. So sorry about this technology fail. These are the calcium levels that we see in Washington. So what I have here is the limited value that we should be sitting. So this is minimum value that we would like. There's no toxicity unless we get to values very high, so 56%. When you have levels of 15 or more of milliequivalents of calcium, we tend to think that we have calcium carbonate, so that leads to high pH. But the availability of calcium in your soils is pretty high, except for those soils that are sitting in a very sandy area. So that's where we see the low percent of calcium in soils like this. This is the level, this is 106 samples of, for potassium. So again, we are sitting in very high levels. Before coming to the US, my range was normally between the 100 and 300. 300 being high, especially for varieties like Honeycrisp. We got soils here in the Yakima Valley with 600, 700, and probably the lab people that are here sitting will agree with these values. So we are in very high levels of potassium. This is the pH map of Washington. And what it shows here is that in the eastern side of Washington, we have very high pH. The darker the color, the more negative or the more limiting in terms of pH. And in our survey, we have more than 16% with 8 and more. And that will limit the availability or the uptake of some nutrients. Okay, so now which I will give you very quickly because we don't have time to go over this every element, but just a main idea of how we would like to manage this there in Washington. So not that quickly, but I will start with the easier ones. Oops, sorry about that. Okay, so micronutrients. This is a limitation when you have high pH. The best way to manage this is by foliar application. So you will try to maintain your soils in adequate range, but because the soil have high pH, or sometimes we have lack of drainage, excessive water will limit the uptake of these elements too. So the best way to manage this is by foliar application because are required in very little quantities. And so even if we don't have high efficiencies in the foliar applications, something will get there and we can improve the efficiencies and the uptake of these elements. And because they are required at different timing and they don't have very good mobility in the plant. So the spray applications are very important in the growing season when you see this type of symptomatology. For more information, you can see the WSU Crop Guide Protection. And this is what I'm talking about. The iron is the most limiting with this type of the pH that we have in the eastern side of the cascade, but we also have limitations on the uptake of these other metals. Now, for all the elements except for nitrogen, what we would like to do is to be sitting in this adequate range in the soil. So first, you want to make sure that you correct your soil levels to be in these values, in these ranges. And I do want to caution that there's a lot of different methods that are provided by different labs. Make sure that if you're going to use this table, you use the methods that are validated for Western soil, and those are the ones that are scientifically validated that you can contrast the values with. If you use a method that is not like this one, you will have trouble to understand what is the contrast or what is the standard that you have to keep those soils in. So first, start with correcting the soil's values. And then for nitrogen, and once you have everything corrected for all the other elements, we're gonna think about this equation: demand, very simple, demand minus supply, and an efficiency for nitrogen. Pretty sure I'm running out of time. Is it the problem of to the back? There. So This table is available for you in our tree fruit webpage, and it shows the demand of different elements for different varieties, but we also have it for apples, for pears, for other crops, for Washington. So take these are, I believe, are very reliable source of information in terms of what are the ranges that we should be applying. And here is an example. If you have 10 tons of fruit, very easy number to use, you have a range between 19 and 49 of nitrogen, and the rest of the numbers you have here. Again, you can see how little of calcium is needed for 10 tons of production. Once we have the demand, we have to think about the supply. And for nitrogen, we use a very simple estimation, which is consider 1 pound of nitrogen per % of organic matter in your soil. And that range is here is between 7 to 14 pounds for each % of organic matter. So if you have 1% of organic matter, you will have between 7 to 14 pounds of nitrogen. Okay, so that's the supply. And then water supply. This is very important. And I didn't account for this at the beginning. When we start working here, a lot of water that you irrigate with do not have much nutrients, but there are sources of water that have a lot. Especially, these are samples that are, that I'm giving you here are results from actual water quality from irrigation in the area of Marua. Please account for that input, especially when we think about nitrogen, and look at the amount of calcium that we are putting into our orchards just with the water. And this is very easy to calculate. So the lab can give you the amount per, and of course you need to know how much water you use to irrigate. We use a very standard number for cherries. There's a literature that show actually double this amount in terms of irrigation, but that was from 10 years ago, so I wanted to go a little bit more efficient in the water use, but this is the amount of nitrogen that we are putting in that orchard, just by the irrigation. So that needs to be accounted. And then we have the example. So if we go to very conservative, let's go to the higher number of demand of nitrogen, for example, here minus the 7%, the 7 pounds that come with the organic matter. Let's go with half the irrigation, even more efficient in irrigation, and we have 12. With the water supply of the irrigation, we only need to apply 30 pounds of nitrogen in a year for 10 tons of production. Now, of course, the efficiency is important. I'm not going to get into the efficiencies and how we can improve those, but of course, you have to think about irrigation methods, timing, source, and placement, all those points that I list here. And if you want more information, there's our webpage down below. I think that was the last one. So with that, I finish. And of course, if you have any question, many of you know my contact information. Please reach out and share your results with me. I'm happy to learn with your results, but also to share with the industry.